today we're going to focus on surface area, specifically that of prisms and cylinders. Now, a few basic definitions for the unit is a polyhedron, which is a three-dimensional figure whose surfaces are all polygons. A prism, which is a polyhedron with two congruent bases. The base is the face of a polyhedron perpendicular to the height. And the lateral faces are sides of a polyhedron other than the face. So we look at this diagram here. We have an octagonal prism. The bases are the two octagons, and the lateral faces are all the sides connecting those two bases. Last thing we need to talk about is the height, which is also referred to as the altitude, which is perpendicular distance between the bases, or base and the vertex. So here the height is in blue, our bases are in pink, and then the lateral faces would be the white. Now we have two types of prisms. Traditionally we see right prisms, where they look like they're standing up straight. But you can also have them kind of look like they're tipping over, and we call those oblique prisms, where our sides are not hitting directly at right angles. So here's just some examples of right prisms, and then what they look like when they're oblique prisms. Now we name polyhedrons using their base followed by the type of polyhedron, such as prisms or pyramids. So this first one has a rectangular base, so we call it a rectangular prism. Here, although it looks like a rectangle base would be, the actual bases are the triangles, because there are two of them versus three, and we call this a triangular prism. And then lastly, we have a five-sided figure, so it's a pentagonal prism. Down below, we have some pyramids. Now the first one is a triangular pyramid, and then we have a hexagonal pyramid, again named by their base and then the type of shape. A few more things we need to be familiar with are lateral area versus surface area. Lateral area is the sum of the areas of the lateral faces. So it's all these sides that connect the base. It's adding up the area of the five sides in this example that connect the bases. The surface area would be that lateral area plus adding the areas of the bases. So we have lateral area on the sides, and then surface area, pardon me, surface area is the sum of all of the faces. To find the lateral area of a prism, you multiply the perimeter of the base times the height. So the perimeter of our base here is 3, 4, 5. So we add those together, we get 12. The height is 11. So our lateral area is going to be 12 times 11, or 132 square centimeters. Surface area is found using the lateral area. So you add up all those sides, plus you have to add up the area of the bases. And there are two of them, so you must double it. So to find the surface area of this prism, we take the lateral area, which we already know of 132, and we're going to add that to the area of the bases. Well, our bases are triangles, and to find the area of a triangle, it's half base times height, and since we have a 3, 4, 5 triangle, we know it's right. So our height is 3, our base is 4, so half 3 times 4, which is 6. So our surface area is going to be the 132 lateral area plus 2 times the area of our bases, so 2 times 6, or 144 square centimeters. Our cylinder is the exact same formula, base times height, or perimeter times height, but remember, perimeter of a circle we call circumference, which we find 2 pi rh. So to find the lateral of a cylinder, we say 2 times pi times radius times height. So in our example, the lateral area, the radius is 2, and the height is 4. So 2 times pi times 2 times 4, or 16 pi. And we'll just leave it in terms of pi for this video, because it's much easier than working with decimals. And again, the surface area is going to be the lateral area plus the area of those two bases. And just a reminder, the area of a base of a circle is pi r squared. So our surface area is lateral area plus 2b. Well, we know our lateral area is 16 pi, and the area of our base is going to be the radius squared, 2 squared, or 4 pi. So we add the 16 pi plus 2 times 4 pi, which is 8 pi, and we get 24 pi centimeters squared. Let's look at just a couple more examples when we're talking about surface area and lateral area. So in our prism, the lateral area is going to be perimeter times height. So I used 20 and 9 and added those together and doubled up. I got 58 for the perimeter times the height of 8, or my lateral area is 464 square centimeters. My surface area is going to be the lateral area plus the area of those two bases. So the base then is going to be 20 times 9, or 180. So we're going to add our 464 for our lateral area plus 2 times 180, which gives me 824 square centimeters. Now we have an oblique cylinder here, but we find the lateral area exactly the same. So we're going to find the lateral area by 2 pi RH. So our radius is 5, and our height, remember, has got to hit at a 9-degree angle. So it's going to be 15. In this case, it's outside our cylinder. So 2 times 5 times 15 is 150 pi centimeters squared. And surface area, we're going to take that lateral area, so it's like the wrapper of our can, and we're going to add 2 times the area of the bases. Well, area of the base is pi r squared, so r squared is 25. So our area of our base is 5 squared, or 25 pi, and twice that is 50 pi. So we add 150 pi plus 50 pi, and we get 200 pi centimeters squared for our surface area of our cylinder. Find the surface areas of each of these figures, pause the video, and see if you can get the right answers. For the first one, we get the lateral area of 480 centimeters squared, which gives us the surface area of 672 square centimeters. In the second one, we get the lateral area of 72 centimeters squared, which gives us the surface area of 108 centimeters squared. And in the third one, we get the lateral area of 80 pi inches squared, and we get the surface area of 112 pi inches squared. Pause the video, check that your work matches mine. And that's it. We are done with surface area of prisms and cylinders. We will practice these in class.